Jialun. It's really hard to pronounce. You can also call me Julian if that makes you feel more comfortable. First, I want to make sure that no one is man of steel or people with super weird ability. Tell me that you're not seeing anything from this remote.
Nothing.
Nothing?
Not a thing.
Okay, good. How do I turn the camera?
Oh, sorry.
Oh, yeah.
I did magic.
I actually know how to do that.
Yeah.
There we go. You did it.
Okay. So
It's running.
if this is my phone, not sure if you can see that too, but let me just do this using. Now, if I'm pressing any button, you can actually see the light, right? Can you see the purplish light on two of the diodes? And the reason these cameras can see lights that you cannot is they don't have a perfect coating for filter out infrared radiation, which I'm going to talk about in a moment. So what I want to talk about is seeing the unseen. The light spectrum we are most familiar with are these part, which is the visible spectrum. It is what the sunlight reflects off us, and then we can see colors. So light, as scientists discover, can be described as particles or waves. And if we talk about them as particles, we call them photons. And if we are talking about waves, there's an equation that describes some basic properties. C equals lambda f. Lambda here is the frequency of the wave, and lambda is the wavelength of the wave, and f is the frequency of the wave. C is the speed of light. Speed of light is a constant, as that the Einstein have assumed, which hasn't been disproved yet. So higher the wavelengths, lower the frequency, and vice versa. And this is an intuitive way of looking at the waves. The distance between this crest here are what we call wavelengths. And if they have a long wavelength, the frequency of this wave is small. And so this is of a higher frequency. We classify light into many regions depending on the wavelengths, because different light of different frequency or different wavelengths can interact differently with material. Some of which we can see, but that's a tiny, tiny band in the whole spectrum. And the visible light spans from 400 nanometers to around 700 nanometers. 1 nanometer is 10 to the negative 9th meter, which is really, really small. But that's and when the wavelength gets below 400 nanometers, is what we call ultraviolet light and or ultraviolet rays. And above that, when the light has longer wavelengths, we call them infrared, which are the light these remote controls generally use. Cameras can see color because they have sensors that can detect light, and they're, depending on the electronics and the mechanism, they're either called charge coupled device, which is CCD, or complementary magnetic oxide semiconductor CMOS. If you don't understand this, don't worry. We are not going to quiz you on anything. These CCDs are actually colorblind, so cameras usually have a layer of color filters. These are called, this is called a Bayer mask, and on the Bayer mask, there are a lot of tiny color filters that let through only one kind of light. There are mostly 2 green, 1 blue, and 1 red filters in each square grouping. The reason for putting 2 green filters is because human eyes are most sensitive to the green region of the spectrum, and the consumer-grade cameras are usually made to imitate the true color or what humans see. So in order to imitate stronger perceive of green light, we Bayemask used like 2 green filters on it. On many good traditional cameras, there are one more layer of filter to filter out the infrared light. So if you do the experiment shining infrared light onto your phone, if you're using an iPhone, you are unlikely to see that because iPhone is expensive and they filter out the IR radiation, because the infrared radiation can actually be recorded by the CCD, and they might be misinterpreted as green or blue or red colors, as the Bayer filters are not perfect. So aside from imaging with the visible part of the spectrum, which is a very tiny part along the whole spectrum, we can also image using infrared rays. The reason of using infrared rays to see things is that our atmosphere has a high transmission rate, so infrared light can propagate through air easily. It's not that a thin air or the air atmosphere can block infrared. That's why we can use remote control that operate under infrared instead of, say, ultraviolet. But probably we don't have ozone in our room to block that. So here are some sample pictures taken at different frequencies. So this is the traditional visible spectrum picture, which use the red, green, blue scheme picture. And this picture is taken using the near infrared, which spans the wavelength is about 700 nanometers to about 3,000 nanometers. Because we human cannot intuitively see infrared, so there's a artificial coloring here. The brighter, the more intense the infrared is, the brighter the color is in this picture. And then if we go above to 8,000 micrometers to around 100,000 micrometers, we can take pictures with what is called the thermal infrared region. And the reason it is called thermal infrared is that objects at around room temperature will radiate infrared radiation according to some weird quantum physics theories. So thermal infrared imaging looks pretty much like this, but we introduce false coloring so that you can see what is going on the screen. And on this picture, this is basically how the object is represented by a brighter light, which I'm going to show you in live. So this is what you guys look like under the thermal camera. Can you guys see this over there?
I can see it.
Very good. Notice that it is different from what is on the screen there because I use a gradient coloring here, and the white color represents the hottest stuff. So there is a bar over here. Wow, static. This bar is a reference for the coloring in this picture. So you can see like the whitest part, whoever is over there has around 34 degrees Celsius of temperature as perceived by the thermal camera, I can change the coloring to a cooler one. So if I use a rainbow coloring, the red color would represent the hottest object. I can also use the same coloring scheme on the screen. So I took a couple pictures last night in the evening, which is also on the handout. Now you can look at your handout. So there are 4 pictures on the first page, and those were images I took. The one on the left upper corner is some footprints. Well, there are 3 footprints, and you might be able to distinguish the bee's footprints from human footprints and the bunny footprints. And then see if you can spot those tiny those tiny white objects on the lake. If you can recognize that's a lake. There are actually lots of bees. So maybe spend 2 minutes, talk to your neighbor in the group to think of some applications for thermal infrared imaging.
Huh? How long is that thing? I try to take 2 separate videos of each speaker, so this one's at 11 minutes right now.
What they actually use as far as how you use for military.
Think of applications about thermal. Whatever. You should start listening. You should start listening. Kind of glad I moved the camera away before I did that. Shot it at everyone in the classroom. Walk around, take breaks at whatever he has.
Okay, let's come back as a class. We'll start here. So, what do you guys think?
Well, we came up with a few ideas. One, we can see like if there's a fire in a house, like what the door's behind, or like where it is. And then she came up with ghost hunting. I don't know.
Ghost hunting can be used in movie making. You can, well, but I don't think we can see ghosts with infrared light. But using infrared, the thermal infrared imaging in firefighting is actually becoming more and more popular. This is a firefighter actually, and he's also using the thermal camera in a drill. So what do you guys think of?
We came up with like if someone's running away from the cops, the helicopters use the camera to try and find them, like if they're in the woods or something.
Yeah, that's definitely one application people have been using. What about you guys? Military use, for example? Outside use. That's not so much about that. But yes, that's one way thermal infrared can be used. So what's the group in the back think about?
Hunting in the military.
Yes. So what do you guys think about?
CIA stuff.
CIA surveillance. And what do you guys think?
Like military drone strikes.
What do you think about that? Military thing. Okay, but that's right. That's one good application. And what do you guys think?